But first, about shipping market. And some of you, for instance, those of you who have been working in SDX or Hyundai may, of course, know a bit about this from before, but I suspect that many of you are not really, haven't been thinking too much about the shipping market. So this is a slide I showed earlier on. So we are about here now. We are going to talk about shipping, market trends, ship types, and but we will not cover everything that has to do with ships in the time to come. We will go a little bit back and forth here. Okay? And at the same time, and the reason for this is also that I want to get into the ocean energy sort of thing, so that those of you who are working on projects relevant in this area will have some input in relation to your topics. So we'll go a little bit back and forth here. But all the time I will give you very, very clear headings for what I'm talking about. So there's no reason for you to get confused, even though I will go a little bit back and forth. So, of course, there are many types of ships, and there are many ways of dividing ships into various groups, right? You can do it in a very coarse way, lump many types of ships together, or you can do it in a finer, more specific way. Also, when it comes to shipping information, there are many sources, and I will give you the website for many of these sources. But the thing is, very often you'll find that the data or the statistics you are interested in are not available unless you pay $1,000 or something like that. So I have been able to get some of this information, and some of them is also open, but for, let's say, for a shipping company, a ship owner who really wants to have information about the competition will very often have to go to a source like this one and pay money to get the statistics. And we'll talk about many of these types of ships later in the course. Liquefied gas with LNG carriers, LPG carriers, chemical, crude oil, oil products, dry bulk, and dry bulk combined with oil, OBO, general cargo, passenger, ro-ro, with and without passengers, container, of course, we'll spend a good deal of time on. Also passenger cruise, we'll talk a little bit about. Not fish catching or offshore. But what you often see in statistics is that they have kind of a cutoff line when ships are smaller than, let's say, 300 tons. They are not included in the statistics. So very often if you have a reference to the number of ships in the world, you'll see different numbers because they have a cutoff where they don't count the smaller ships. And of course, there are very many very small ships. So have that in mind. So when we talk about the world fleet, we talk about number of ships, of course, and we talk about the size of the ships. And here you see deadweight tons, which is a size reference for bulk, container, gas, general cargo, other passenger, reefer, that's a refrigeration, ro-ro, and tanker. And very clearly you see in terms of size or tonnage that bulk and tanker are the big categories, but container is coming as a very, very large number 3. And when it in this statistics, you see that general cargo and other smaller ships, that is very large when it comes to number of vessels. So, for instance, here you see other 50,000 vessels. So they are smaller vessels, and that's why I hinted to you that when you look at statistics, it depends on whether these are counted or not regarding. Did they do something? Okay. Regarding the numbers, okay? So, in order to confuse you completely, I've listed various ways of measuring the size of ships. And gross register tonnage has to do with the outer volume of the ship. And you can imagine for a passenger ship or a cruise ship, the size of it is really much related to the volume of the ship. And the net register tonnage is the volume of the cargo space. And the gross tonnage is again with a factor. And some of these units, like gross tons, when you start going into it, there is a formula that is kind of combining different things. So it's not a simple way of understanding the size of the ship. Then the Panama Canal has a separate system for calculating the size of a ship. And why is that? Well, of course, you have to pay according to how big the ship is that goes through the canal. The same with the Suez Canal, but they have a different system. I can tell you one interesting example, and that is in LNG. You know, there are two major types of LNG ships. One is the membrane tank, where most of the tank is, well, the tank is inside the hull itself, right? And then you have the spherical tank, the Moss Rosenberg design. And it turns out the way the cost, the fee for going through the Suez Canal is counted, it's much more expensive to go through the Suez Canal with the spherical tanks than with the membrane tanks. And to the extent that this has really distorted the competition between the two types of technologies. Because, you know, these spherical tanks, they increase the outer volume of the ship. And it accounts to very much money when you have to pay to go through the canal. So it's for two ships of these two different types that carry exactly the same amount of LNG, the fee for the spherical tanks, the Moss design, will be significantly higher than for the other one. Displacement, and of course that's the weight, actual weight. That's according to Archimedes, isn't it? So how much water displays is the same as the weight of the ship. You have the light weight, and then you have the dead weight, the carrying tonnage. So be a little bit aware of what kind of tonnage we're talking about. Whether it has to do, let's say, more with volume, or for typical cargo ships, one would rather talk about the dead weight, the cargo capacity, right? Whereas for a cruise ship, the weight of the passengers isn't that significant in terms of, what it carries, right? So there are different ways of doing this. So, and again, numbers of ships, and this is for is this for about 300 ton minimum size? Yeah, but in this case the reference is about 50,000 ships. Again, depending on how you count, the world fleet may also be said to be more than 100,000 ships. So what are the largest shipping flags? And we talk about flag states, we talk about port states, we talk about the coastal states. So the flag state is, simply the flag that the ship carries, that is where it's registered. And here we see something that has happened recently. And what are the main flag states? Well, you see Panama, Liberia, Bahamas, Marshall Islands. Well, Singapore, we kind of can understand, Hong Kong. But you see, many of these countries are tiny countries with no shipping tradition. Liberia in Africa? So it's quite obvious that they are, to a large extent, flags of convenience. And why? Well, it has to do with taxation and it has to do with regulation, right? And there's more and more being shifted over to these particular countries. So you'll find, let's see, Norway here. We used to be the third largest flag state in the world. Tiny Norway. We had an enormous fleet. But you'll also find that very many of the Norwegian ships are under these flags that you see up there. Of course, United Kingdom, about the same fleet as Norway. Again, the UK ownership will be up there. Same with the United States. So that's the situation. So the flag state as such doesn't necessarily mean very much in terms of a real home for the ship. And very many of the ships have never been to their flag state. And there's a steady growth of ships, and here you see the number of ships is in thousands, 100,000 ships at the moment approximately. And if you look at this curve, you see that the gradient is about 1,200 ships per year. It goes back to 9 after the war. Does that mean that only 1,200 ships are built per year? No. because of course there's a lot of scrapping going on, right? So the ships that get old, they are taken out of service, right? So more than anything, this growth, or the number of, the growth has to do with the increase of the world fleet itself. So that's the number of ships, but there's another factor which is more important, and that is that it's not only the number of ships that's growing, but the size of the ships are also growing. So the ship types are changing, right? One very, very significant change is from small general cargo ships to huge container ships, for instance. Completely different technology. So there's a lot of change going on. Much more dramatic than this curve is showing you. And I think this, we can make many types of statistics, but this one is quite interesting, I think, because what it shows is how the world fleet has grown since 2002, up including 2008. So this is pretty recent statistics. So over these years, you see this is tonnage here, and you see the growth. And you see when it comes to oil tankers, the fleet has grown by 32%. Chemical, 10%. LNG, nearly 60%. Bulk carriers. And this UBO type, is that? I'm not sure if that is plus or minus, because that is a ship type that is... No. I don't understand that. 90% container. That's in terms of capacity, passenger. So you see there is some ship types that really are growing much stronger than others. And of course, if you are the owner of a shipyard, it's important for you to understand how the market is growing at different pace, different speed in relation to ship types. So in this case, it's very clear that container is the market that is growing fastest. So I won't bore you with too much statistics, but again, it's important that you are able to read statistics. So, for instance, if you look at the world fleet, total number of ships by type and size, and here you see different categories. You have small ships, less than 500 tons, medium, up to 25, and large from 25 to 60,000 tons, and very large, larger than 60,000 gross ton. So of course you can read many things out of this, but when you look at, for instance, oil and chemical tankers, oil tankers mainly, you see the rather few in numbers also of small categories, whereas you see very large is the main size of oil tankers. also for other types, you'll see that, for instance, the container ships as a trend typically grows towards larger and larger ships. So bulk carriers too, very small growth in the small sector, large growth in the big sector. And this is something we have talked about before, economy of scale. Right? It is normally more efficient to carry a specific amount of cargo on big ships than on small ships because, of course, you have fewer voyages. And this is similar by gross ton. So this is, you can look at the tanker fleet, and you see numbers, and you see deliveries per year, and you see the number of ships scrapped. So you see the number of ships, of tankers, has grown quite a bit during recent years, and even more in terms of deadweight tons, that is carrying capacity. So that, and typically for oil tankers, that is very much tied to the world economy. So trends in the world economy has an immediate effect on the number of new contracts for new ships. But of course, when it comes to ships that are under construction, they are in the pipeline, so to speak, so they will come out even if the economy suddenly starts going down. Then there will be a delayed reaction when it comes to building new ships. So some kind of correction, if you like. And similarly for bulk, you see exactly the same thing as I've talked about. The number, there's a growth, and I think in a few years we'll see a dip, particularly when it comes to deliveries, and then probably also the amount of scrapping will go up for a while, and then there will come a new wave of building new ships. So shipbuilding is a rather sensitive business. And for instance, what we saw a year ago, almost no new orders. Very bad situation. Of course, there were quite a few ships under construction that will come into the market, and hopefully the market will then pick up again by the time that is delivered. But of course, the fact that there have been so few new ships in order will give an impact on the world fleet in the years to come. So we'll see something like that in a couple of years. And this is also what you see with the container fleet. Even there hasn't been a real dip, but there has been sort of a continuous demand for container transport. Now it's beginning to pick up again. So the world economy is recovering. And you may have heard also that they have been talking about kind of a double recession, a double dip curve. Well, it looks like that is not going to happen, fortunately. So things are beginning to look brighter, even though it may still be a difficult time for shipbuilders. So, when you look at the age of the fleet, you can also read quite a few interesting things. And it really fits with some comments I made a little bit time ago. So when it comes to new ships, it's really dominated by very large ships, and small ships. You see that 47% of the small ships are more than 25 years old. That's dramatic. It's so dramatic that I would wonder if that will, has to be corrected somehow. Because when these ships get to be very old, of course they are unsafe, there's a lot of maintenance, and there may have to be scrapped. And for instance, in the Mobile Harbor project, the focus is on rather small ships, isn't it? These shuttles that can go out to the container ships and bring the containers ashore. They would belong in that category, and it will be interesting to see if we'll have a structure in the future where there's a better integration between the very large ships and the smaller ships, which is really the idea behind the Mobile Harbor concept. Yeah, this is the same, but it's gross tonnage, so I won't spend. New ships, and of course, when it comes to new ships, general cargo and container, bulk and oil are the main types. You see there's in numbers quite a few general cargo ships, but they are small ships. So they are not so much, they don't impact the tonnage very much. So there you see that. Yeah, and here you have the tonnage. So general cargo now is down to 3%, whereas oil is 37% in tonnage. So it's quite obvious that the oil and bulk and container are the three main categories in terms of capacity. And order book development, yeah, you can see the different types of ship, but even here you can see a dip in the order book starting around 2004, and how far it has come down after 2006. I've not been able to get the statistics for, but again, this shows something that you should be aware of, and that is the sensitivity of the shipbuilding market in relation to the demand and the economical variations, right? Look at this. So it goes up and down. So new orders is very, very sensitive. So in one way, one can say that this is a rather risky business, isn't it? And this is the order book for tankers. Yeah. Up and down, up and down. Very sensitive. Containers. And unfortunately, I don't have the latest statistics here. This is up to 2006. So I'm sure we'll see some of these variations for the last 3 years. Okay. Then I put together this one. I'm not a historian, but I kind of pick up certain information, and this is an unscientific presentation of shipbuilding through history. Okay. So going back to 3,000 years BC, the Egyptians, that was kind of the leading culture, right? And they had ships not only on the Nile River, but they had ocean-going ships on the Mediterranean. And then, as it typically happens with the very big nations, they flourish for a period of time, and then they go more or less under. Then came the Greek. They were also great seafarers, and you'll, with some few exceptions, like the Mongolian Empire, but most empires are tied to having a strong fleet to control a large area. So the Greek, for instance, controlled most of the Mediterranean, and then came the Romans. They had their great period from, let's say, 200 BC to 500 AC. China had a great period then, and I've been free enough also to write Norway up there, because the Norwegian Vikings, of course, were the first to cross the Atlantic with their Viking ships, and they established colonies. So the small country of Norway established colonies in France and in the British Isles, Iceland, Greenland, even all the way over to Newfoundland in North America. So that was based on a ship technology. And of course, then came the colonial powers of Spain and Portugal, right? So when they started establishing colonies in Africa and in South and even North America, it was all based on ships, right? So they had to be good shipbuilders. And then, of course, England was able to win over Spain in a few wars, etc. And you had the great period of England with colonialization, and again, to a large extent, based on ship. Then, of course, the Germans had their time around the Second World War with the biggest warships ever, and they were able to control the seas for a while. United States, also around the war time, but not. U.S. has never been a great shipping nation, even though, of course, U.S. capital is behind a lot of financing of ships. Then we have the small neighbor of Norway, Sweden. And do you know Sweden was the biggest shipbuilder in the world around 1970? Did you know that? It's quite remarkable. And one can ask why. Well, of course, they had the steel, Swedish steel. They had big, mines for iron ore. They had a steel industry, and they had subsidies, right? So they had very, very good conditions for establishing shipyards. And as these shipyards were very successful and built bigger and bigger and more ships, for instance, in the city of Gothenburg, there were 3-4 very large shipyards. Well, if you go there today, there's no shipyard in Gothenburg. It collapsed in a year or two because the Swedish government realized they could not keep on subsidizing this industry. So they cut back the subsidies, and the whole thing collapsed. Today there is one shipyard in Sweden, and they build military ships. So it's kind of scary, but it's important to learn from history. And of course, Japan became the greatest shipbuilder after Sweden. And then came Korea. And what we have seen now is that China is surpassing Korea. And of course, one of the reasons now is also that China builds a lot of ships for itself. Of course, it builds for other ship owners and nations, but it's part of the Chinese policy, I believe, to make sure that as much cargo as possible that goes to and from China is transported on Chinese keel. And since it's the most populous country in the world, there is intrinsically a big market. So, again, what I have presented is not, strictly correct historically, but, things are happening more and more quickly, isn't it? I mean, you have your great period and then it's over. And before, these great periods may have lasted for hundreds of years. Now they may be lasting for a decade or less, right? So it's important to be aware of this, and particularly I think for authorities, subsidies is not a good thing because that is not sustainable. It will collapse. But at the same time, to have the right competitive conditions for an industry is important, right? So it's to a large extent also the responsibility of the authorities, but of course the industry itself has to be very much aware of things are getting more and more competitive. And what is my answer to that situation? Innovation, right? So that's why we are having this course. So this is from 2008. Korea built 50% of the ships. Is this tonnage? Yeah, this is tonnage. That was 3 years ago. What is happening now? Well, China, 70% of all new orders, July 2009, were received by Chinese yards. Well, of course, the recession had started hitting, and China also building ships for itself has been less sensitive. But you can see 2006, 8, 9, and of course we don't have the numbers for 2010 yet, but there is tremendous growth. And they may have some difficulties because of this tremendous growth, of course. Because it cannot continue to grow like that for many years. So there are many Korean shipyards. I found this on the net somewhere. I'm not sure if it's representative at the moment. So I'm sure some of you know some of these shipyards. You find both HHI and SDX here, Daewoo, Samsung. So what are the options when you have to become more and more competitive? Well, of course, you can specialize. You can focus on building one particular type of ship and become very, very good at that. But what's the disadvantage? Well, the disadvantage is that you'll be very vulnerable to variations in the demand, right? If you are focusing on a very narrow sector and you don't have alternative things to build or produce, you become very vulnerable. So the opposite is then, rather than focusing on the narrow thing, is to get broader, right? That's what we call to diversify, to have different products. So it could be different ship products, but it could also be that you start getting into offshore wind turbines or something quite different, right? So then you have the possibility, if one market goes down and one goes up, you may be able to shift your resources over to the other, the growth sector. And of course, you can focus on being better at production, right? To become more price competitive. So that has to do with organization, logistics, having more robots, industrial robots and automation, and of course also at the same time focus on quality, which can be an important competitive factor. Another thing one can do is to move up the value chain into more, let's say, valuable ships. So what is a very valuable ship? This one is very valuable, right? Costs maybe $1 billion US. That's a lot of money. So, of course, when we look at the statistics and we see one ship, number of ships compared, but the value of the ships is very, very different. So, for the price of this one, you can buy maybe 100 other ships, smaller ships, right? But there are also some small ships that are extremely valuable. For instance, in the offshore oil and gas business, they need some very, very advanced both supply and ships to assist the production. And some of these ships are not that big, but the value of one supply support vessel for offshore industry, the value of one ship can be the same as an ultra-large crude carrier. So, and that's, for instance, in Norway, our ship industry has been surviving because of building these high-value ships, as well as supplying equipment for other sectors of shipping. Yeah, that was the last one. So I'm not sure This was maybe not so much about technology, but I would like to give you a better understanding of the shipping market. So that's why I spent this hour on this topic. So has it helped? Maybe you should also spend a little bit of time going through this presentation and see what you can find out. Okay, let us start again. And as I mentioned when I started the lecture before the break, we are going to talk about climate change and shipping, because the environmental challenges are important and you should understand what it's all about. Because this is an area where there is definitely a strong need for innovation. So I'll talk about this for the second hour today, and on Wednesday you may remember that we are going to have 2 hours again to catch up for Monday that we skipped last week. So on Wednesday we'll start at 1 o'clock again, and we'll talk more about the environment and sort of finish about the environmental challenge in shipping. So during the rest of the week, then I'll talk about what is the climate change, what are other aspects of environmental problems. Also important, what is public, what is society expecting when it comes to environmental performance, regulations, and certainly something must be done. What can be done to reduce the greenhouse gases, saving energy, reduction of pollutants, we'll talk about all of this, and innovations and technical measures. What again can be done in terms of technology, but it's not only a technological problem. Have you heard about or discussed climate change in other classes? No? Of course you have been hearing about it in the news media, reading in the papers, etc. But it's important to have maybe a little bit more system understanding of what climate change is. And I must say there's a lot of misunderstanding when it comes to what is influencing climate change. I was earlier this year listening to a lecture by a professor of economy who had been heading a committee for the Norwegian government regarding the economical challenges of climate change. And he asked during the lecture if we wanted to hear about what is causing the rise of temperature. And he said, well, you should know this, but I raised my hand and I wanted him to explain what this climate change and the greenhouse gases was all about. And he gave an explanation that was completely wrong. He hadn't understood what it was all about. So, he kind of said, you're stupid if you don't understand what this is about. But in his own explanation, he was quite wrong in explaining the mechanisms. So it's not just about insulating the earth, it's about a rather complicated mechanism. And this is a figure that of course, shows some of these factors. Where does most of the energy come from? Of course, it comes from the sun. So it's the influx of energy and radiation from the sun, even particles, that is a great energy input to the Earth. Then, of course, there's many interaction effects, and this is really what makes it very complicated. When the sun and the sunlight comes to the surface, of course, some of it is reflected, for instance, on the sea, ice. Ice reflects more than sea water, but that also does reflect light. Then you have thermal radiation, heat radiation, both from the ocean and from land. You have a lot of human activities in terms of factories that spew out heat, water, greenhouse gases, and a lot of things. You have volcanic activity. You have, of course, a dynamic system with the biomass, that is in terms of trees and plants, but it's also biomass in terms of microbic and smaller organism that is on a very, very large scale. All of this has to do somehow tied to the CO2 cycle, and which again is influencing the greenhouse effect. But what this slide doesn't really show, and that is the importance of the ocean. You can list a lot of effects in terms of what's on land and what's at sea, but when it comes to the CO2 cycle, the biggest resource or the biggest storage of CO2 is by far the oceans. So the effect of the oceans is not fully understood yet. So when they do calculations in the global, the climate models, there's still some uncertainty with regard to the importance of the ocean, how that exchange of CO2 is happening. And there's also certainly a great deal of uncertainty regarding the chemical processes up in the atmosphere. So we still, I would claim that we still don't have the full science for understanding the climate changes. We just have to admit it. And unfortunately, many of the scientific groups, they claim, to have the answer. But that's not, in my opinion, that's not true. Of course, with science we can understand more and more, but there are still some very big question marks. And it doesn't help that, you hear that so and so many climate models have predicted from 2 to 8% global warming in the next 100 years. And one could, and now you have to be a little bit scientific, one could claim that, well, maybe the mean value is a good representative. Yeah, we are very used to taking kind of the middle value, right? But if all of these models, if all of them are lacking important parts in the model that's still not understood, they will all be wrong. It doesn't help if there are 1,000 predictions. If there are important elements in these mechanisms that are not understood yet, they'll all be wrong. So, therefore, it's important to do research and increase the understanding, but it's also important to be aware that we are probably wrong when it comes to most of our predictions about the future. And recently, I think, and there's been in the past a lot of rejection with regard to the importance, for instance, of sunspots, the variation of the flux from the sun. Now they are beginning more and more to realize the importance of variations of the energy input from the sun itself. So that's how it is. But we talked about the sun and the reflections from the clouds and from the surface, be it on land or be it on ice or be it from the sea. But really what is the great concern is what's happening in the atmosphere, where you have different gases and you have humidity that contributes to when the reflection comes from the earth and goes back. These are normally a little bit more long-waved light, and it turns out that with these greenhouse gases, their effect of reflecting what comes from the earth back to the earth is extremely important. And that's where CO2 comes into the picture. That's where methane comes into the picture as greenhouse gases, and they are reflection gases that sense the heat that radiates from the surface of the earth back down. So a greenhouse, where you grow plants, is typically a sort of a trap for energy in terms of light and radiation that comes in but doesn't get out as easily as it came in. So changes in this atmosphere and the different layers as we have around the world, the globe, or the earth, I should say, it's an important aspect here. Okay, so be aware it's complicated. Then again, you can look at a lot of statistics and you see a lot of warnings. And this is CO2 in the atmosphere, it's methane and nitrous oxide, NOx in different combinations, I would think. And here is statistics showing these tremendous growths in greenhouse concentration of greenhouse gases from year 0 to year 2000 and whatever we have now. Well, what would you say when you see statistics like this? Do you think they could measure this when in year 0? They didn't even know that there was something called CO2, did they? Not at least methane. And when you see statistics like this, right, with a lot of accuracy, so to speak, how is that possible? Well, of course, they have done something like looking at the gas composition entrapped in ice, little bubbles in ice, and they can date from the position in the ice when this air was trapped. Well, of course, that is one factor, and typically such a factor is used to backtrack how this has developed. All these measurements have really been done here, right? But then by looking at, for instance, entrapped air in glaciers, in ice, they have been able to come up with something like this. But still, I think we have to ask questions about, is this correct? What we can see here, the growth with modern instruments and satellites and all of that, that we can believe. This I'm more skeptical about, personally. Okay? But the problem is there. So what are the problems? And in my opinion, and in one way it's not politically correct to say something like that, but the main problem is the growth in the world population. Of course, we want people to have a good standard of living, and as the population grows and the standard of living grows, the consumption of resources per capita goes up also. So the total effect of population growth and getting a better standard of living, which of course is very positive, all of this puts a tremendous strain on the limited resource that is our Earth. Right? Now there are predictions that towards year 2050 there may be kind of a flattening of the growth, and that also has to do with better education and standard of living, etc. But of course, we are approaching 10 billion people on this relatively small Earth, and that is in itself a great strain, and it is a great challenge to be able to deal with this without even further damage. And many of you have been involved in the CO2 transport problem. And how can we now reduce the emission of and release of CO2? Well, if you look at the energy needs towards the time, demand for energy, when you relate that to the population growth, right? And let's say the expected increase of standard of living, that will be a curve like this. We already have problems here, and what in the future, of course, the problems will be much greater. Then maybe able to replace some of the energy that produces CO2 with renewable energy. And CO2 neutral, that could also be, for instance, biomass, even though that is disputed. So by doing that, we can also be able to deal with through new technology, become more efficient, and we look at, this would be the ideal situation where we really could reduce the emission of CO2 through better efficiency and replacement with renewable energy. But that's easier said than done. So really to bring this curve down is a big challenge. But that is in the political, on the political agenda in most developed countries. So because of the climate gas, because of other factors like variations from natural variations, we also see that we have an effect on our activities on the ocean, like shipping and offshore activities. So the environment loads from the wind, currents, and the strain also representing raising sea levels and changes in ice extension. All of this kind of the environment that we have been talking about fighting back at us, so to speak. So the environment loads, we influence the environment, and the environment influences us, right? And we experience these changes because of a changing climate at sea. So we see rising levels and water temperatures, polar caps, ice caps melting, severe storm frequencies, changing weather patterns. Then, of course, we can, through technology, become better at understanding and describing what is going on. We have weather stations, we have ocean recording buoys, floaters that can record temperature, current, size of waves, etc., etc. So we are getting more and more information. We have also recordings from ships, and we have wave radars that can be put on ships, record the sea in front of the ship, lasers, and of course more and more also very, very sophisticated satellites, Earth observing satellites. And we can do modeling, numerical simulation, and we can also get more and more information from statistics, of course. So the understanding is getting better and better. But what has come up now is because things are changing, for instance, our design requirements for ships, there's some questions being raised if our design codes are adequate, if they are good enough for this situation where we see more severe weather. Of course, part of it, and I would say part of it, is due to the fact that we have been able now to observe more. Of course, when we get better at observing, then we can record more storms, right? When we get better at measuring waves and have more information coming in, then we see that, we count more extreme weather situations. So things have to be sorted. One has to be critical, but let's say there are indications of a more severe climate at sea, which has consequence for ships, and it has consequence for offshore structures. It has consequences, for instance, for offshore renewable energy. If we are going to extract energy from, let's say, waves, of course, that is good if you have more waves, but on the other side, your energy absorbing structures have to be able to survive even more severe weather condition, right? So survivability becomes very important. When you look at, and again, you can show so many things with statistics. Look at this curve, recent sea level rise. And here you have centimeters, right? And from year 1880 to year 2000. So that's a 120-year period. And so there is, well, of course, when you are back here, we didn't have much, maybe, climate influencing activity from humans. But certainly we have had that here. And of course, one typically would say that this rise in sea levels is due to human activity. Yes, maybe so. Regardless whether it comes from humans or it comes from natural causes, this is something we have to take into account, right? Of course, we can blame it on ourselves, and we probably should do that. But then you can go backtrack more in history. What do you find? Well, you know, it's not, and this is probably much more correct than many of the other things we have been looking at in terms of old statistics, because it's, you know, when the ocean has a shore, right? It makes a mark, so it's not that difficult to see what the sea level has been through the history. And look at this. If we go 20,000 years back, the sea has risen about 120 meters. 120 meters. Then we are back in the glacial period, right? A large part of the northern and southern hemisphere were covered with ice on land, right? That's where the water was. So it's dramatic, right? And this is before we had invented the automobile or airplane or, you know, engines. You know, nature is brutal. Nature is really dramatic. So even though we have this kind of thing going on now, things have been happening much more quickly in the past. For instance, you know, when you are back in this period, you could walk from England to Europe. I mean, that part of the North Sea was land. So dramatic, isn't it? And we have, of course, a great challenge with this flat curve. Imagine if we had today's developed society and we were living in these times, right? That was very dramatic. But in Norway we have a funny effect, because we still have the land rise effect of the glacial period, where there was some places 2,000 meters of ice on top of the land, right? We still have the effect of the country rising from the ocean, and it's rising still faster than the sea level is rising. So we don't have any problems with rising sea levels. But if you go to the Maldives, you know, this island country out in the Indian Ocean, Maldives, they are very much afraid of that their land will disappear due to the rising ocean. And that's very understandable, but again, you know, nature is cruel. Some of you may be working with maybe Professor Choi on freak waves or wave hydrodynamics. There's been some very, very severe accidents with ships hitting freak waves. And freak waves or rogue waves are very, very out of the pattern, very large waves that suddenly arise, and one has become more and more aware of that this is the situation, and there have been many cases of big damage due to these very, very large waves. But again, they've probably existed all the time. It's just that now we are beginning to understand that they are there, and also how, from a hydrodynamics point of view, they can arise. And there's something called the nonlinear Schrödinger equation that can help explaining why we have this out of the ordinary, very large wave amplitudes, like you see in this statistics, and then suddenly an enormous spike with an enormous wave that normally is kind of three half waves with one very large amplitude, and that can make a lot of damage. So this is one example of a concern that we now are becoming more and more aware of, and we have to design for these extreme sea conditions. Then there's something called the IPCC. Have you heard about that? That's the, well, very much of the information about climate change that we get today come from this intergovernmental panel on climate change, which is under the United Nations. And of course they also got the Nobel Peace Prize 2-3 years ago for their work on the climate. But of course there's a lot of discussions going on, and I try to give you some of the background for there is uncertainty, and IPCC has been subject to a lot of criticisms lately. But there is general agreement on that human activities does influence the Earth climate. And but how much is natural variation and how much is the human influence, that is hard to say. And this conclusion is generally accepted. Climate models are sophisticated, but there are effects that are not fully understood. So there may be a kind of common weakness to all of these different models. Influence of the sun, I mentioned, natural climate cycles, but the precautionary principle, and that is, you should take measures, you should be aware sort of in front, even though you are uncertain. If the potential for damage is there, you should take the steps to try to avoid these consequences. Okay? So there's one famous report from 1987, the Brundtland Report, Our Common Future, and that has really been the basis for a lot of the attention over the last 20 years or so on the climate problem. And there are different scenario models. So the fourth report of the IPCC came out in 2007. I believe the next report, the fifth report, comes out in 2014. And in the last report, they have different scenarios having to do with whether we solve the problem on the global level or we leave it to separate countries to do what they feel is right. And then it depends on focus on economy versus focus on environment. So one can make typically scenario models and do some analysis on that basis. So that's what they have done. And there is a growing concern, not only that The climate change, it may make it uncomfortable for us, but it may also have a great economical impact. So there's a famous report by Lord Stern, Climate Change and Economy, and climate change gives a 2% detrimental impact on the gross domestic product, I guess, in Great Britain. Of course, again, with a certain amount of uncertainty, but there is certainly an economical effect of climate change. Now we get into our topic. More than 2/3 of the world transport of cargo is done by ships. Think about that. If you look at ton-mile of transported goods, shipping stands for 2/3. That's quite amazing, isn't it? But when it comes to total emissions of CO2, it's about 2 to 3% of total emissions created by human systems. 10 to 50% of the NOxes and 4 to 6% of global sulfur. This has to do with the sulfur content in kind of fuel that the ship are burning, and there are coming new regulations that will be very strict on sulfur in these marine fuels. Bunker oil, okay? So what are the releases? What comes from a ship typically that would have an effect on the environment? Well, ballast water. We're going to talk more about ballast water. But a large ship can have tens of thousands of cubic meters of ballast water. And this is a great concern at the moment, the new regulation coming, because of ballast water can bring with it not only microorganisms, but also larger organisms, and when they are released in a different place than where you took in the ballast water, you can have these species that are alien to where you are, and these alien species can do a lot of damage. And it can bring with it disease and all sorts of things. So I have an idea of a ballast-free ship, so if any of you would be interested in that, we could talk about that. Anti-fouling. Do you know what anti-fouling is? Fouling is, these are some terms that you may not have heard before, but they are very important. Fouling is when there is organic growth on the surface of the ship. It may be green, slimy things, or it may be small shells that grow. And this can have a significant effect on the resistance of the ship, because you have more surface friction. So you have to use more fuel in order to maintain a given speed, right? So how does one deal with that? Well, of course, paint with toxic components, poison, so to speak. And in the past, for instance, use of heavy metals, even lead, but now we know how damaging lead and zinc to some extent, and so other materials can be. So one is looking for new types of paints that would reduce the amount of fouling and the fouling, chemical effects, their toxic effects on the environment is something to be concerned with. Then, of course, there's black and gray water and bilge water and all sorts of water that comes from the ship that also can contain pollutants, garbage, oil and oily mixtures. One great concern is, for instance, when you have oil tanks, you go back after delivering a cargo, the tanks have to be cleaned, and they typically steam them or use hot water to get these oil residues. And unfortunately, much of that is let right out into the sea. So that is very, very bad. So to get a regime where one would be able to deal with that kind of waste from a ship is important. And one way of doing it is to have proper facilities for receiving waste when you come to port. But then again, that is costing money, so it's very, very tempting to just let these things out in the sea where it's doing great damage. So, CO2 comes from the chimneys, NOxes, sulfurs, VOC, have you heard about that? Volatile organic compounds. Those, you typically get fumes from your cargo, or it can be from your from the gases, you know. For instance, if you have an LNG ship and you release the vapor up in the air, then you have this effect. Well, how do you deal with it? Well, of course, you can cool it down and put it back into the LNG tanks, or you can use it as part of the fuel for propulsion of the ship. Then there are particles, and you know, particularly before using in fire protection and that sort of thing, chemical substances that can be harmful for the ozone layer. And this, all in all, health, environment, and climate in the ultimate. So this is something that we don't like to see from a ship. But it's also something that it's possible to do something about. And this is one of the big, big challenges now for the future. Let's see. Yeah, I'll go through this very quickly. One has recordings and models for gas releases having to do with the ozone layer, sulfur and nitrate, how much is released in the various ocean regions, as you can see. So we don't know exactly how accurate these figures are, but again, I have to show a beautiful picture of my country. So this is the famous Geiranger Fjord. Geiranger Fjord. It's on the United Nations Heritage List, which is, you know, one of the most beautiful spots in the world. It's very, very popular for cruise ships to come in here. You have the high mountains. You have lots of waterfalls, you can see some glaciers, etc. It's so beautiful. But the fact that it's becoming so popular sometimes gives this effect, right? This is the same place. You see the ships down here, and you can see the releases from the chimneys. In the future, I don't think the cruise ships will be allowed to do this. So one may have to resort to much cleaner energy sources on board, at least when you are at port or near land like this. For instance, fuel cells. But when you're lying on the fjord, you cannot have an electric cable brought out either. So you have to have systems on board where you, to a much better, larger extent than is the case now, deal with exhaust fumes from the cruise ships. And the cruise ship needs a lot of power even when it's not going anywhere. You know, to maintain, you need electricity on board, air conditioning, and so on. So you have the auxiliary, the assisting machinery on board that has an effect. But if nothing is done, one is going to see that also the emissions from ships will take a greater share of the total CO2 emissions in the future because the fleet is growing so fast, right? It has to do with population growth, it has to do with higher standard of living, greater consumption, more transport, etc. on ships. But if you look at the political targets that EU, for instance, says that industry from land should decrease by 20% the CO2 release by year 2020. So how does shipping fit into this? There's a great challenge. There is going to be a big political pressure on the shipping industry to really reduce the emissions. So even though you can say that percentage-wise, shipping doesn't contribute that much to the CO2 pollution, if that starts, continuous growing, whereas other industries have to restrain and reduce, that is not going to be accepted. The public, the people won't accept it. So something has to be done. And that's where the good brains have to just really start working to do something with this. And there are many things that can be done, and we are going to talk more about that on Wednesday. Yeah, maybe I should get back to this one on Wednesday since we have used up our time today. So I go through this a little bit more, and then we get more into the shipping technology as such. Okay?